Let's continue our conversation about quadrilaterals and their properties with a few examples where we're going to have to apply the properties. Okay, so let's see what we have. KLMN is a rectangle. For that reason, because it's a rectangle, we know a lot of things. We know that this side is congruent to this side, this one's congruent to that one. The opposite sides are parallel because it is a parallelogram. Some other obvious things, right angles all around. You don't have to label all that, but it's there if you need it, okay? So they tell us that KL, this distance, is 6x minus 6, and NM is 4x plus 10. And then they also say that KM, which is the diagonal, let's stop right there. Let's not clutter the picture yet. Let's go ahead and deal with this and this. So these two sides are congruent. Opposite sides are congruent in a rectangle, in any parallelogram. So we're just going to solve it. We're going to subtract 4x from both sides, add 6 to both sides. Cancel those. We're going to have 2x equals 16, so x equals 8. Good to know. And then KL, well, KL is 6x minus 6. That would be 6 times 8 minus 6, which is 42. 42 inches, feet, light years, who knows. Okay, now let's switch colors. KM is this diagonal right here. And that entire thing, that entire green piece, is 6y minus 7. Now, when we draw the other one, which I'm going to draw in red, don't know why, just to look Christmassy, I guess, we're going to have LN, and that one is going to be 5y plus 3, and the problem is sometimes when you draw things like this and you've drawn these two lines that intersect or these segments that intersect, you might think, oh, 5y plus 3 is just this side. So just be careful that you understand the context of what's going on. But basically, what we are going to do is find the value of y, because one of the things we know about rectangles is that the diagonals are congruent. So let's take that idea and run with it as well. So 6y minus 7, which represents this entire diagonal, is equal to 5y plus 3. And we'll subtract 5y from 6y, gives us 1y. We'll add 7 to this. It's going to give us 10. Y is equal to 10. Good to know. 10. Not writing all my answers in the same color, but that's okay. Now we're going to find all the other little things we need to find. And so LN is 5y plus 3. Well, that was red, so let's just stick with red. So 5y plus 3. You can do this in your head, but I just wanted to give you a visual for it. So that's 53. All right, so there's 53 in red. LM, oh no, how are we going to find it? Okay, now things get interesting. Now things get really interesting. And we're going to find this distance right here doing some really old stuff, but I want you to notice what's just happened. This is 42. This is 42. This is 53. And what we've done at this point is really clutter up our picture, but what we have is a rectangle that has 42, 53, and the thing we're looking for, 42, 53, and the thing we're looking for, that's a right angle. So let's just stop right here and say that LMN is 90 degrees, just saying. I know that, you know that, it is a rectangle, LMN. So I'm going to use, you guessed it, the Pythagorean theorem. If you're looking for this one, call it whatever you want. A squared plus b squared equals c squared. So a squared plus 42 squared equals 53 squared. And so a squared is equal to whatever 53 squared minus 42 squared is. I'm going to write a little bit too much work here in case you need to see the work. And we'll do 53 squared minus 42 squared. And, sorry, it's 15 over 3 is equal to 5. Yeah, I didn't type that. No shame if I did. Take the square root of that. So 32.33. We'll stick with that. 32.33 is what we have. 32.33.